Thank you. Okay, so let's move on to the next presentation. Oren Nakdimon from MoveIt will tell us about Oracle sessions and how they can communicate with each other despite social distancing via the old familiar DBMS pipe and DBMS Alert packages. Oren is an Oracle ACE director, a busy blogger, and a speaker at various events and conferences. Oren, the stage is yours.
Thanks, Pascal. Hi, everyone. Let me show my screen. Okay. So, as Pascal said, my name is Oren Nakdimon. I'm an Oracle ACE director from Israel. I am an Oracle developer for almost 30 years, 28 years, I think. Started with Oracle 6 and SQL Forms 3.0, old stuff. I work for MoveIt, where I'm responsible for the database development and administration. And I use the nickname DB-oriented for my activity in the Oracle users community. I tweet about Oracle stuff. You are very welcome to follow DB-oriented. And I write about Oracle stuff in my blog, dboriented.com. And today we'll talk about some old features existing since Oracle 7. I'm going to show you a live demo on Oracle 18 on my laptop. I planned to do it in the cloud on Oracle 21, but I have some networking connection issues here. But believe me, I did it on 21, and I did it on Oracle 7 back in the 90s of the previous century. So we have sessions that are connected to the database, and sometimes we want them to communicate with each other, to pass some message from one session to another. And you may say, but everything is communication between different sessions, right? Because all the sessions are connected to the database. One session inserts records, the other session selects these records, so they communicate. But sometimes this is too much. Sometimes we don't want the overhead of the persistent layer. We just want one session to pass some message to another session without even involving transactions. And it is true that all the sessions are connected to the database, but they are also connected to the shared memory of the database, the SGA. And Oracle implemented the concept of pipes, the same concept of pipes as in Unix. And we can define a pipe, some area in the shared memory, that one session can write to it and another session can read from it. And you can think that every session has two buffers, two local buffers. I called one inbox and the other one outbox just for the concept. These are not formal terms. And suppose that the session on the left side wants to send some message to the session on the right side. So the session populates its local buffer, the out buffer, with one element, a second element, a third element. And then when the message is ready with all these elements, it simply sends it to the pipe. And the local buffer is emptied, and the message moves, the whole message moves to the pipe. And then the other session can read it into its local inbox, local buffer. And then it unpacks it. It reads the first element and then the second one into local variables. And it's important, the order of elements is important. We need to read, to unpack the message in the same order it was packed. And this makes sense because if we are talking about communication between sessions, there is some protocol that we both should know and agree about. So we unpacked all the elements into local variables, and then we can do anything that we need to do with this stuff. Let's see how it happens. And for this demo, I implemented a small logger utility. And this is a classic use case for pipes. I have many sessions that are connected to the database, and I want a single point of logging. It can be a file external to the database. It can be a monitor just to show every message that arrives from the various sessions to one central place. So I wrote a package. I called it pipe demo, and it has two procedures. A log procedure to write something to the log, and every session can call this, every session with permissions, of course, can call to the log procedure, and the consumer of the pipe, the central logger, will call the procedure get next, and will get log after log one at a time, and will do whatever it will do with it. In this case, it will simply write it to the screen. Let's take a look at the implementation. So first of all, each pipe has a name which should be unique within the instance, and the PDB actually. So I gave it a name, demo log pipe, and the procedure log simply gets some text, and then it creates the message. And the way we create the message is simply by calling pack message, dbms pipe.pack message, and we pass. I decided to pass first of all the user, then the SID, the session ID, the host, the current time, and the actual text we got from the caller. Note that we can pass the 5 basic data types. There are 3 overloads for pack message with number, voucher, and date, and there is a procedure for row data type and for row ID. I'm not sure this is the best idea to pass row IDs between sessions, but it is supported. And then once we filled all the elements, we built the message, then we send it. And you see that we don't indicate where this message is, because there is only one buffer for the out messages. So we just packed the message with elements, and then we send the message, and we just specify the name of the pipe. Once again, I cannot say from where because there is only one buffer. So I'm sending the message, and by that, it will go to the pipe, and my local buffer will be cleaned. That's it. Very simple implementation. And the implementation of the other side, the get next, it calls the receive message procedure, specifying the pipe name, and it gets the first message that it's in the queue, because the pipe is simply a queue, first in, first out. If I call it and the pipe is empty right now, I will just wait here until there is a message to get. And I can define a timeout. So we receive the message, and then we simply need to unpack it. And as I said, in the same order, the original session packed it. And we unpacked the elements into the out parameters. And that's it. And once again, we support the same 5 data types. Okay, and I wrote a small Java program for the logger itself. The logger, first of all, does all the connection to the database. Nothing interesting here. And then it prints the header line and calls process requests. And process requests parses the procedure get next, binding the out parameters, and then in a loop, it simply executes the call to get next until it gets the message abort. Okay, it calls execute update, gets all the elements from the message, and prints them to the screen. That's it. So now I'll just a minute. I will show you everything on my database. So I have 2 users, demo 1 and demo 2. And here is the here I will run the logger itself. Okay, it prints the header line, and then I'm running the script. I'm calling pipedemo.log with this is a test, and immediately we get the message by the logger. Let's send another message. This is second test, and let's do it from the second session. We'll have a OUG day, and we get it. And then I'll send the message abort, and the logger says bye and shuts down. Okay, very simple. Now, usually we have for every pipe is intended for some specific purpose. And we have one consumer, in this case, that simply in a loop gets the messages from the pipe. And many sessions write to this pipe. And here in this example, we have 2 pipes. Every one of them does something else. We have several sessions that write to each one and one consumer for each pipe. And of course, the same session can send messages to both pipes. Depends on the need. Now, what will happen if I have 2 consumers that read from the same pipe? Pipe is a queue. And once we receive the message from the pipe, it no longer exists there. So it means that every message will be handled by one of the sessions. And I wanted to demo it. And for that, I want something like this. I will have 2 sessions and I will have 2 loggers. And I want at the same time to send, say, 20 messages from the first session and 20 messages from the second session. And then I want to show that each message will be handled by one and only one logger. So for that, I added another procedure, send many logs. It gets some text and how many times we want to send the message. Let's see the implementation. So I have a simple loop for I in 1 until I how many. And in the loop, I simply call pipedemo.log with the text that I got and the number of the iteration, so we can see the difference. But I want both sessions to start sending the 20 messages at the same time. And for that, I need some mechanism, because it will be very fast, right? Sending just 20 messages is fast. So this is why I want to synchronize them. And for that, we have another utility from Oracle. This is Dbms Alert. And this is a signaling mechanism. Like pipe is like pipe in Unix, and alerts are like signals in Unix. And the concept here is a concept of broadcasting. Sessions that want to get alerts are registered to the specific alert. And then when someone sends a signal to this alert, it propagates to all the sessions that are registered to this alert. So in my case, oh, one more thing, important thing, this is implemented in the database using a table. There is a table in the sys schema, Dbms Alert info, and this is a transactional mechanism. So in order to use this mechanism for synchronizing my two sessions that want to send lots of messages, I define here an alert. Once again, the alert name should be unique in the database. I called it demo alert. I call dbms alert.register for this specific alert. And then I call dbms alert.wait1 on this alert. And then my session will wait here until it gets a signal from this alert, until someone sends a signal to this alert. I can get a message through this alert. I'm not sure it's a really good idea. I'll talk about it more later. There is another procedure named wait any, and then I wait until I get any signal to any of the alerts I registered for, and then I will get as an output which alert happened. In this case, I don't need it because I have only one alert. And then once I get the signal, I send the messages, and finally I remove, I'm calling dbms alert.remove to unregister for from this alert. And this is important because we don't want the alerters to do extra work if nobody is listening. Okay, and I'll touch it later more. And there is also a remove all procedure, simply to unregister from all the alerts I registered for in this session. And this is important. We are talking all the time about the context of a session. I register from one session, and then I will get the signals as long as I'm connected to this session and I didn't remove, didn't call remove. Okay, so let's see it now in actual life. So I'm starting one logger, and I'm starting the second logger. I should write logger to start it. And now from the first session, I am calling send many logs, ABC, 20 messages. And it waits. It waits to get a signal. Let's do the same from the second session, send many logs with some other text. And it waits as well. And now let's, from another session, call Dbms Alert.signal to demo alert. Now, nothing happened yet because this is a transactional mechanism. And now I need to commit. And once I commit, the two sessions send 20 messages each. And let's take a look about the result. We can see here that the first logger handled ABC 1 and 2, and the second logger handled ABC 3. And the first one, the second one handled test iteration 1 and 2, and the first one handled 3. In short, each message was consumed by one of the loggers and one only. So the important thing is that if we need to have multiple consumers for the same pipe, and this can be a very legit case if, for example, there are many messages that are sent from various sessions, and one logger, one consumer is not enough to handle the rate of the messages. So it is okay to have several consumers as long as we know they are symmetric, that I, as a sender, do not know which consumer will handle my message. Okay? Okay. Now, until now, we talked about a mechanism of send and forget, right? The session sends a message and it hopes it will be handled by someone. Sometimes we need a mechanism of send and get a response. And for that, we cannot use the same, we can, but it will be a big mess to try and use a single pipe for both directions, sending a message and then getting a message back through the same pipe. A much more elegant solution is that each session that sends messages will have its own pipe for getting the responses back. So here, for this session, I created a pipe for this purpose. And then when it sends a message from its outbox to the pipe, one of the elements in the message is the name of the pipe for getting results back. So when this consumer handles the message it got, it will do whatever it needs to do, and then it will create a message with the response, and it will know where to send it to. This is the pipe name that it got as an element in the original message. And then the response is consumed by the original sender. And each session can have its own pipe for getting the responses back, exactly the same way. Now, we can do it synchronously. The first session sends the message and then immediately it waits to get the response, waits on its own pipe. Or alternatively, it may be asynchronic. It sends the message and then does stuff. And then at some point, it waits to get the response from the handler. this handler. Now, it's very convenient to use this built-in function, dbms pipe.unique session name. It creates a unique name that can be used for the pipe for a specific session. So this pipe and this pipe can be simply created. The name can be simply the outcome of unique session name. And if the same session will call multiple times to the same function from this session, it will get a consistent result. Okay. This is the last slide, so I'm on time, Pascal. It's okay. Thank you. And I just wanted to summarize the perhaps to compare these two mechanisms. So DBMS pipe, as I said, it's a queuing mechanism, a simple, very simple queuing mechanism, or named pipes, as it is called in Unix. And Dbms Alert is a broadcasting or signaling mechanism. The implementation in Dbms pipe is via the SGA structure, some structure in the SGA, while Dbms Alert is based on a table. Dbms pipe is not part of any transaction, while Dbms Alert is transactional. Regarding the consumers of a specific message, as we saw in Dbms pipe, we have a single consumer. Each message will be consumed by one and only one consumer. With Dbms Alert, because it is a broadcasting mechanism, there may be one consumer, there may be multiple consumers, and there may be zero consumers. If nobody is registered for a specific alert, then sending signals to this alert will do nothing. Actually nothing, because there is no record in the database to update. Can the publisher of the message may be blocked while sending the message? A pipe is limited in size. So if I send some message to the pipe and another one sends another message, and we reach about 8K or so, and then another one wants to send a message and nobody consumed the messages, then the new one will have to wait until the pipe is being consumed. And we can see it as a wait event pipe put. With Dbms Alert, because it is transactional, there is a risk here that we need to be aware of. If one session sends a signal to an alert and doesn't commit yet, and another session wants to send a signal to the same alert, it has to wait. This is a regular row lock, TX lock. And this is why we need to be careful about it, and usually to send the alerts as the last thing of a transaction, so it will be committed immediately after that. If nobody is registered to this alert, nothing will happen. So, but it's not an interesting case. And finally, can messages be lost? So yes, because with pipes, if the instance crashes or just shuts down, the SGA is wiped off, and messages that are pending there will get lost. With Dbms alerts, this is why I said it's not a messaging mechanism. If I am registered to an alert and multiple sessions send signals to this alert, I will see only the last one. Okay, if they sent it and then I called wait one, I will get the only the last alert. So if we use Dbms alerts to send messages, some messages may be lost because I will see only the last one since the last time I consumed these alerts. And that's it. And if you have any questions, I will happily answer. Okay, so Chris is asking, have I used pipes or alerts in a real system? If so, can you share details? So yes. And regarding the pipes, it was a long time ago for logging mechanism for writing something that is quite similar to the demo I showed, but it was more with many more details. And with alerts, without showing too many details, there is some process that does a task that I don't want many sessions to do. I want a single session to handle some task that it is a CPU consuming. It has lots of processing to do, and many sessions do think that should wake this process. And alerting, the Dbms alert is very good for this stuff, because I have this one process that listens to the alert, and every time that it needs to work, it works. And it's better than just looping over and over again, hoping for work to do. So, and I have and other examples, but maybe I'll write about it. Pascal asks, as one alert to be consumed by all registered consumers, as one alert to be consumed by all registered consumers before sending the same alert again? Not sure. Pascal, can you ask? Can you unmute yourself?
The question is not mine, but Clemens, can we give the microphone to Pascal?
Yeah, Pascal, you should be able to talk.
I'll try. If I send a certain alert and I have two consumers, and consumer one consumes it and consumer two not, and then I send the same alert again, will consumer one see the second alert or not?
Yes, it will.
It will.
It will be two separate signals, because each of the sessions has a record in this table Dbms alert info.
Mm-hmm.
So after the first one consumed it, it got cleaned.
Okay.
And the second one still waits because it didn't consume it.
And it will see the second alert only, as you mentioned.
Right, right.
Okay, that's how I imagined it. Thank you.
Thanks. Any other questions? To get a message, the consumer has to know the name of the pipe, right? Yes, this is right. Now, there are public pipes and private pipes, and we can create the pipe explicitly or implicitly, but these are details that I don't think worth mentioning in a 30-minute session. And yet, I've just mentioned them. But I do have to know the name of the pipe that I write to and that I read from. Yes.
Okay, if we don't have any more questions, I would say thank you very much, Oren. It was great to have you here.
Thank you.
And yeah, hope to see you soon. And
Thank you.
we will continue